So I've been given this thing here to have a look at. It's a repair job for someone. This actually belongs to Rob, Sour Packing Technologies, the Siglent guy from New Zealand. He visited me on the weekend and he bought me a few gifts and he gave me a scope to fix, gifted that to me, and some various componentry as well. Let me go scavenging through his drawers. Don't misinterpret that. And he asked me to look at this thing because apparently it's not working. Display, something's completely dead. It's an industrial UPS. I know nothing about it apart from what Rob told me. Apparently he's had a little bit of a look at it, but apparently the front panel's dead and it won't turn on. We'll have a look at it and see if we can figure out what's going on. It's got a special plug. Interesting plug. The pins are turned around compared to what would normally be an IC connector. Not quite sure what that's called. If you know what that plug's called, put it in the comments down below. The first thing we'll do is try powering it up, see what happens, and we'll go from there. I mean, I don't know if I can fix this. I might be able to fix it, may not. Could be a real pain, could be easy, could be hours and hours of work, could be 5 minutes. Don't know. We'll find out. So the first thing I notice is this plug's a bit loose, like this. It's not actually being held by the gland like it should be at the grip. Brown wire's starting to pull out, so it's pulling on the wires. So the first thing I need to do is fix this plug up. Not too hard, but I'll get this done first. You don't need to see me do that. Well, I said I wasn't going to bother you with it, but I'm thinking I might do. So the wires in here are actually trimmed off way too long. So it wasn't actually pulling out, it was actually fully in. But they're left way too long and there's all this exposed wire, which is not great. So if I put this on, need some practice on putting plugs on. There shouldn't be exposed wiring. Obviously you've got exposed terminals, but the wire should still be enclosed. And also the cool grip, I'm not even sure was ever fitted because it's up this way, which is meant for narrow cables. And this is quite a thick cable. So I think that cool grip was probably never actually installed on this cable because it will need to go the other way up. I'll fix this up. Well, I've done those wires and put the cool grip around the way which I think is right, but it's not gripping very well. It's still sliding slightly. So maybe we'll try the other way and just see if I can get it to actually grip on, but the screws probably won't actually make it. But the fact that it was screwed right in before means this thing was actually never done correctly in the first place. I did manage to get it in there and you see it's bowing those out. I can't really do any more than that. I'm going to end up stripping it or something, or snapping these legs off. That now doesn't pull and doesn't turn, so I'm happy with that. But yeah, that is not what it was like when I got it, so yeah, it wasn't right from the beginning. Now seeing as that was like that, let's do a quick earth check of the actual casing and stuff, make sure it's actually got a decent connection. Going to a screw there, come on, get through the paint. Let's go to the back panel, we've got a decent connection. Yeah, 0.6, so yeah, that's earth, that's alright. And check for any faults, obvious faults. We've got meg-ohms to there, meg-ohms to there, and across these two, meg-ohms to there, so there's no obvious faults, that's alright. I'm happy to plug that in. Let's turn the power onto it and we'll see what happens from there. Start off with 7 watts and it's creeping up. 24 watts, 26, 27. Either it's going to go bang or it started charging because it's got batteries inside, obviously because of the UVS. It could be ramping up the charging. Seems to have stopped about 40 watts and it looks like it's coming back down again now. Yep. So it looks like it's probably fine. Let's try powering it on. Let's see what happens. On. Pushing it does nothing. Holding it does nothing. Select does nothing. Off. Pushing and holding. Okay, so yep, as expected, as described by Rob, it is completely dead. Now on some UPSs I found if you push the button it doesn't do anything. And you push it and hold it down for like 5 seconds or a few seconds, something like that, then it'll come on. This isn't doing that. Definitely not that. Alright, so power is off. I've taken the screws out. Well, I think I have. Alright, here we go, it's moving. There's some batteries. That's why it's so heavy. So we've got 6 gel cells in here. Not sure the capacity, but they look like 7.2 amp hour cells. Maybe 9. One or the other. Either 7.2 or 9. Filter board, it's not a power supply, it's a filter board. Oh really? Anderson connector behind the metal panel. Was a metal panel just here? Slot. It's called an intelligence slot. It's got a cable going to that too, so something else could potentially be in there. What does this say here? 6 pieces, 12 volt DC, 9 amp hour batteries. Okay, so yeah, 9 amp hour batteries. So this side's not got really much to see there. We've got, say, a filter board here, which may or may not be right. I mean, we're consuming power, which means I can assume that the power's getting through this board, not shorting on that board. and getting through to the batteries. We could turn the power on again whilst monitoring voltage. You've got a link here, so it's be positive and negative right here at this end. Serial string. So that means that's running at 72 volts. Positive negative there. Don't stick your fingers across those, 72 volts. Let's have a look, see what we're actually getting. Then we'll turn the power on, see if the voltage seems to be climbing with power. That'll confirm whether there's any actual life in the batteries as such. So I'll stick one here, stick one there. What we got? 72.3 as expected. Can I shove this in there, make it stay? Okay, 72.3, turn the power on. 85, yeah, okay, we've got live charge in the batteries. 85 going in, so that's fine. So that's trying to charge, which means it's not completely dead. Let's check each battery. So we're getting 72 there, which is nominal battery voltage, which means they are down a bit. Although they call 12 volt batteries, they actually sit a bit above that. I was expecting to see sort of 12.6 or so on a static gel cell. So we'll see what we're getting. 11.8, that's very down. 12.4, so that one's worse. 11.8 as well, so that one's actually better than the other two. 12.5, that's a really good one. And 12, a bit weak. And 12 again. So we've got two good cells. So this one here is good. This one here is good. The other four, not so much. Thing is, these batteries aren't cheap. To re-battery this thing, you're looking at 300 bucks. Just put your batteries in it. Depending on how committed you were to getting this thing working, I mean, if it is working, you know, once it's up and going and working, if I can fix it, these batteries, they only last a couple of years. Depending on how the usage is, you know, if they're cycled a lot, they'll be a much shorter lifetime. You can actually get lithium iron phosphates in the same form factor, but the current rating is usually lower. They might be limited to 10 amps or something like that, maybe less. So it depends on the batteries, I think, but of course they have a BMS built into the battery pack. But also like 3 times the price. But they have about 10 times the lifespan. So if you're looking at having something like this and you're going to have it around for many, many years and planning to keep it for, you know, 10 years, then when you get to that point where you want to replace these batteries, going lithium iron phosphate might be an idea. In the long run, it's cheaper and more reliable. I'm definitely a convert to lithium iron phosphate. Since I've had them myself, I've been very, very happy. They perform so much better than gels or deep cycle batteries or whatever. They just do so much better. There's much better batteries. Obviously the charging circuit has to be able to cope with that and that sort of stuff too, but the BMSs will do a lot of the coping with that anyway. So we've got power coming to the battery pack, so power's also getting past this stuff because it's all getting in. Let's spin us around and have a look at what's on the other side of the board. So that's what the other side looks like, apart from being a bit dirty. I've had a look around at capacitors. Visually, no obvious leaks, no bulging, they all look fine. They're Aishi brand, A-I-S-H-I, which I've seen in various equipment and they've seemed okay. I don't know how they really rate in reality, but my experience with them has been they're not too bad. Now I can see some labels over here for rails, so plus 12 volts ground, plus 5 volts over here, marked on these jumpers. So I've got some test points there I can look at. Now these fans on the back, they're not running, which may be a clue that in fact it's not even powered up. Maybe it's because it's not even powered up. But if there's no power on these rails, because one of these switch mode power supplies haven't started up, then that's why there's nothing starting, no fans. I need to see if these supply rails are here first. I will be surprised if they are. And obviously you've got the main switch modes down here. We've got some smaller stuff here. Got one here. There's a couple of small capacitors down there. And it comes right across and there's more over here before we get to the big stuff. The big ones over here, this is obviously for main output stuff and the re-switching relays here too. So this is all the main output to supply the outputs. That probably isn't what's wrong. It's likely to be the primary supplies down here, which would be like a standby supply rails and things like that. So it's likely to be something in this area. This board here, these two cables, they go to the front panel. So you've got a stem one here and a flat flex. Both go down to the front panel. There should be power on this board. So there should be power available on here somewhere too. I'm still looking to see if I can see any more markings for power supplies. There's nothing really so obvious as there is here. So maybe that those are the test points and that's what he uses, 12 volts and 5 volts and that's it. It's possible. But there could be other stuff around too, which I just haven't noticed yet. There is a fuse down there, but I think that's probably fine because the fact it is trying to charge the batteries. Something is happening, which means that fuse there is probably okay. I'm still going to check it. Yeah, so I think the first thing to do is plug it into power and see if I've got anything on these test points up here. We'll do that. Let's check the fuse before I power it up again. Fuse is fine, as expected. I'll plug the power cable back in, turn the power on, and we'll see what we get up here. So that one there is supposed to be a ground pin. I'll go across the side of the jumper. It's supposed to be 5 volts. We've got 0.5 volts, that's not running. And 12 volts, 0.1 volts, also not running. Okay, so if I try and poke into those again whilst pushing the power button, in case anything changes, I'll try the 5 volt rail. It's just nothing. Anyway, we're getting half a volt, and I'm pretty sure half a volt's not right on the 5 volt rail. So we've got these connectors come down, which are supposed to go to the front panel, which obviously if you've got a front panel controlling things, there must be power, shouldn't there? There should be power somewhere which allows you to control that. So let's have a look on this board, see if I can see anything. Bearing in mind that power is on. There are also labels on this board, so let's hook into these test points. There's Martha's ground. There's Martha's 5 volts. Half a volt, that's that one we got before. And we have a plus 12 volts. Nothing either. And then we've got plus 18 volts. Nothing either. So no power supplies. And it's really nice they've got them labelled on the board. Was designed towards repairability. Good on them. That's a rare thing these days. So, must be no power coming from down here. This is going to require a bit more digging. So I just found a little axial fuse just down here. Looks a bit like a resistor, but it's not. Let's just see if that's looking okay or not. Smart as 10 amp. That's fine, that's not blown. Shame. So if there's one of those, there might be more. Yep, there's some more down here. Martha's F. I can see F9, F2. There's a whole bunch of them over here. There's a big bank of fuses right down here by these main outputs over here. So that's a good place to check, is all those fuses. See if any of those are opened. If they're not, then they're definitely going back to the switch mode supply side of things, all this bottom section again. So I'm going to check all these fuses out. Let's just turn this beeper, it's easier to do. Unplug the power cord, just for the sake of unplugging it. It's obviously powered down, but so let's check all these fuses out. Don't forget they've still got a battery power present, so it could still be trying to do something. Fuse 2, that's okay. A bit dirty, but okay. We've got the next one, which is fuse 9. Yep, that's alright. It was a bit hard to get into. Yep. Yep. Good. A little bit of corrosion grub around this one, but it's still okay. Not quite sure what the dirt is there. Okay, so that's all those fuses there. That's all the fuses I can actually see. So all the fuses are good. So it does bring us back to the switch mode supply stuff. So what I'm thinking I might need to do, unfortunately, is remove this board and replace the smallest caps. So there's a whole bunch of small caps, I don't know, there's not that many of them. What was there, 1, 2, 3 small caps? There's one over there as well. Fourth one over there. And they've got medium size, I might just do that one too. Maybe I'll just measure them, see what they're like. Because it's always the small caps which are a problem on switch mode power supplies. So if you're repairing a switch mode power supply, find the smallest capacitors, replace all those. And that usually is all you need to do, because they age quicker. They're a bit less tolerant to failure because they're smaller. There's got less capacity for error, you know what I mean? Any drift on a smaller cap is going to show up a lot more, and with a big cap it's got that resilience there built into it because it's physically bigger. There's a bit more going on there, you can actually allow to lose a bit more. Whereas small cap you can't lose it. I can't really explain it better than that, but basically everything's on plugs. That's really good. And obviously you've got a whole bunch of power resistors and stuff down here too, which you would have seen before. I need to check those to make sure they're not open circuit or something, because that can happen. There's also some diodes around, there's a diode just down there, but I'm not too worried about it. I think it's probably going to be a capacitor problem. We'll replace the caps and see if the switch mode supply boots up, because when it's dead like this, or barely working, which is what you're currently getting, it's usually the switch mode supply is not booting up properly. It's like trying to start and failing. Look at the right place, you can usually see that actually, but I don't know where to look in here yet. So to make it safe before I start unplugging stuff, really simple, we just got to break the circuit of these batteries. So you can pull off any one of these wires, and seeing as these ones are nice and accessible, let's pull off that one and that one, just to make sure there's no floating wire. That means there's no battery power going to the unit now at all, and so that should be safe. So before I start pulling things out, let's make some notes about the wiring here. We've got this long wire comes through the casing, that comes up here. They are marked as neutral and live, and we've got a triple wire here, blue there, brown there, shoulder brown there. One's power supply, well, one's marked as power supply, one's marked as output, I think output. This is OP, so I think those are output cables, and power supply there, so I think there's okay. So a bunch of cables here. I'm not sure if they're all the same, whether they're in powered or not. I'll have to look. If they're not, I'm going to have to look at labelling them somehow. So it's got 3 blacks outside and got 3 reds across this way. They may or may not go to the same places. It might just be purely for current handling capacity. I might just label them anyway, which one's which. So we've got a plug up there, goes to fan 4. Also got these 2 which comes to this. Interesting, is a plug that comes from here and goes back over to there. Back into itself, which is a bit weird. Don't know why I put a plug in there. Strange. It's marked as PFC, so power factor correction. Got a plug there as well, which is the one that goes to the little board on the top on the other side, the little plastic casing. Unplug that one out. That can come out. And then we've got some more plugs down the side, which are fans, so those don't really matter which way around they go. Unplug those, and unplug these ones. Can't get these wrong, hopefully. Plug that one. So it's pretty straightforward. Now I've got to take the screws out and hopefully it'll just lift out. We'll find out. So I've got all the screws out, but I think I need to take this board out, which looks like it's on a header. So I think this board's got to be lifted out as well. And unplugged, so then I can lift this board, the big board, upwards to get it out. It's not looking too bad. The board, I mean, say the board's moving around, but I think I need to do something with this. I think it's on headers. Yeah, it's definitely moving. Okay, right. So let's see if I can get this one lifted off here. Oh, there we go. Right. So there's that board. Got a few surface mount caps on those. I have to check those, see if they're right or not. So hopefully I can lift this board outwards like this. Don't want to grab underneath because there's power in it. Mind you, say the same thing about the heatsink I'm holding on. Okay, there's the board. That fan is seized. That fan spins. That fan spins. So this top fan over here is knackered, that's seized up. So that needs sorting out as well. Yeah, not surprising. Let's check these caps, see how much life's left in them. There's 4 of them right here. These are the ones I'm really worried about, it's big ones. Nothing on that one. Well, that pair, both gone. This one here, 40 volts still, okay. Interesting, on a circuit board here, it's actually got placements for resistors to drain these capacitors down, but they're not populated. No, it's 39. Okay, I need to drain these properly. So let's take a close look at this board. Now this is the top edge, where that other daughter board is plugged into from the side. You can see some dust and garbage around here, which has got caught up on these pins. I'm cleaning anything off here. Obviously I want to inspect it and see what's where first, in case there's clues which we then destroy by wiping things off. So we've got dirt and stuff around this connector, and just a little bit hung up in various places, nothing too major there. Got a bit of dust marking over here. Spin it around. This is the front edge, and we've got another really dirty bit here. This is where those fuses are, just down here, a whole bunch of fuses. Oh, they're also all in parallel, it looks like. Is that right? All in parallel? They were. So even though I tested each individual fuse, all those fuses are in parallel, so wish I'd known that. Probably marked on the other side of the board properly. But we've got some gunk around here, so that could be an issue. We've got some what looks like delaminating just here. See this? Under this silk screen lifted off, so that could be a clue about maybe traces here being eaten away from moisture, because that's where the fan was. Now I repaired another machine recently, a G4 Mac, old G4 Sawtooth, or was it Gigabit Ethernet, I think it was actually, all look very similar, but they've got a fan right near the circuit board on the power supply, and the fan was throwing junk in, and it actually corroded components right by the fan, and that's what I found in it. So that is in my mind, and as this silk screen is basically flaking away, that makes me think maybe there's something similar going on here, because that's a similar sort of symptom. No, that's right, it's conformal coating, it's a bit of conformal coating around, it's a bit shiny in certain spots. The whole board isn't conformally coated, but bits of it is. There's some bit of conformal coating around here, but then there's bits here that doesn't have any. Why don't let's do the whole board, be better. Anyway, okay, so we've got some clues, we've got some dust up here, dust here, this is peeling off. I mean, I'm just going to just poke around and see what I can find. This is the first thing I'm looking at, the fact that this is peeling off, that's like not normal. So maybe I can follow traces from one end to the other and make sure there's continuity from one end to the other. If there is, then that's probably okay. It could just be moisture affecting the silk screen and maybe nothing else. May have affected traces actually. may have affected traces. Let me get my fiberglass brush and give that a bit of a brush, and we'll see how that looks. Yeah, traces are affected. There's definitely corrosion on those traces. So that could actually be part of the problem, is that the power supply rail is generated down the bottom here, travels up this front edge to get to the top. It's certainly possible. It could come around like this, and so maybe there is power here but it can't get to the top because these traces are knackered. That's my first suspicion. I think that's the first thing I'm going to look at. Scrape all this back and try and check for the traces being badly damaged in some way, but there is definitely corrosion on those traces. So right through, underneath the solder mask, underneath the silk screen, to the traces. Obviously on the edge of the board it's gone through the edge and made it in that way. So that's the first thing I think I'll be looking at, is this bit. So I'm just giving this a scrape, and yeah, there's definitely corrosion underneath this stuff. I only want to go as far as I need to go, but yeah, it's definitely worse around here. And it's working its way underneath the silk screen, so kind of want to get it back to a point where I know it's really good and then reseal it. You can see it's just flaking away here, and even around here it's all a bit dirty. There it is, looking kind of okay. There's a bit there, which big chunk of corrosion right there on the board. Just there. It's actually eaten a hole into it, I think. Or it could just be a wire going through. Yeah. Basically I'm trying to scratch the top layer off and see what the traces look like underneath, and you can see up here is quite bad. There's still copper there, it's not completely gone, but it's definitely going quite deep. I'll have to check to see if they're actually broken or not. This very edge one here looks quite bad, and that's just with the naked eye. Let's try and clean up around here a little bit. But it's looking pretty dodgy. It's got a whole bunch of links there, one side to the other. So it's linking this track to this side. Yeah, well, that's quite bad just there. Let's get a stiffer brush. Yeah, that's definitely been affected down here. I think that was bare solder there to reinforce the traces. Definitely dirty. Definitely got lots of corrosion around there. Even this side as well. And then the actual jumpers on the other side. Look like that. Also corroded and stuff, so it actually calls them fuses. Yeah, maybe they are fuse wire or something instead rather than just jumpers. Interesting. Well, they could just be jumpers. That would explain why I did it that way. But the markers F as fuses. Anyway, I'm going to clean up some of this stuff and then we'll see what I can find out. So I'm just probing around trying to find all the various tracks. I've gone over this with the fiberglass brush as well now and cleaned it up, and it's got a shiny. And they all look intact. I'm just doing continuity testing. And I'm just doing this big track here, which goes to this pad here. That one there, stick into that, stick into here, we got that. Follow the track down, put it there, follows it down to here, disappears. So I've got it to there, and the track goes down, it's broken right here. Right there the track is gone. We've got it, right, over to here, there's nothing. There, there's nothing. There, it's there. So between here, nothing, here, we've got it. So, right there, there's a big gap in that track. Is there meant to be a big gap in that track? I don't think so. I think it's corroded away. I think I might have found it. So I'll give this a scrape up. There's like no trace there. It's definitely gone. There's a definite gap right there. Don't think it's meant to be there. Well, let's just run some solder over this. In fact, I'll run flux over it first and solder, because this is all corroded. So obviously I've scraped all this bit back, but scraping only gets you so far. It's pretty bad. So we'll just do this, and also do the same here. Give this a clean up too. I'll run solder and hot iron over all that stuff, and hopefully it will fix it. Well, at least improve it. So I'm just going to run some solder on here as well, which will just help to coat the copper which I've exposed, basically tin it slightly. I'm also going to make sure I don't bridge it anywhere. Bridging it would be bad, so we don't want to bridge it. Once I've tinned it all with this to get some copper coverage, then I will make sure that once there's no bridges anyway, to make sure there's no bridges, then I will put some solder mask over the top of it to try and preserve it as much as possible and re-insulate it, because otherwise it will just happen again. Just okay there. Really, this tip's a little bit small for what I'm doing here, but it's just doing the job. Just can't do these bits, which is just a mess. Problem is, when you get corrosion on the solder joints, the solder just goes really horrible. Sometimes you can recover it just by putting fresh solder on, it's alright after that, but sometimes you need to remove it. I'm just going to try putting fresh solder on first, and we'll see if that's okay. I'm also going to recoat the track which I've exposed by scraping. So it's basically going to end up like a big blob, but I don't care. As long as it's electrically sound. See, this tip is struggling a little bit with this temperature, with this thermal mass. It's doing it. It's a bit on the small side, that's all. Okay. Just the other side, same problem. Needs a bit of loving. And if you think I'm doing this wrong, say so in the comments. That's what they're for. That bit there's refreshed. Now I need to put a bridge across this track here. So this pad here is not looking the best. Let's do this one. There's a wire there which looks like it might be gone. I'm not quite sure if it actually is or not, whether it's just... I think it is actually. I think that might need some reinforcing. And it may not need it because it is double-sided at that point anyway. There's lots of bits going through, but it's got these big terminals for the battery connections, but they're looking a bit dodgy, so I think I might just put some on there. Give it a fighting chance. That'll do for now. Lots of burnt flux to remove. I'll give it a clean up and we'll see what we're dealing with. Then I'll put a bridge across that track and maybe across where this wire is as well. Right, so those traces are repaired. I'm going to put some solder mask over these now and let that cure. Then I might actually try reassembling it, because I think that might be all that was wrong. So I'm securing the solder mask on, and we'll see how we go with this. May or may not be any good, we'll find out. We definitely found a problem. We had one open track and some corroded ones, which may have been causing problems too. Maybe they were conducting because of the corrosion build up, maybe. It's possible, a bit of leakage. But more likely that open trace that was there was the problem. So I'm going to put this back in again. Well, what I might do is just check some of these capacitors, do some testing whilst the board's out. Just do some basic measurements, some of these caps, and then I'll put it back in again and try it again. Right now, obviously I've got to get the solder mask to go off. This might be all that was required. So I tried to get some solder mask on the edge of the board as well, so that the moisture doesn't get in through the edge of the board. That's what I tried to do. I don't know how effective it's going to be, but this all comes back to being a fan right there, blowing gunk onto the circuit board, adding moisture to it. So let's check some of these small caps. 0.7, not too bad. There's one over here. So it's conformal coating, which might be a problem. 0.9. Yeah, they're not horrendous. I'll check those two bigger ones as well. Right. .4, that's alright. Bigger one over here. 0.6. Big one here. 0.9. 1 ohm, let's get up there a little bit. So not horrendous. 0.9 again. Yeah, I mean, they seem okay. Maybe it could be slightly better, but I'm not worried about those. I think I'll put it back in. Right, I've got the ball back in there. Let's put this link back on the batteries. I don't know if something's going to happen. I'll put this link back on or not. It could go bang. Let's tap it. Okay, a little bit of charge happened there. Something happened. Right, let's plug the power in. I haven't put the fan guard guided shield for the airflow on the other side yet. I haven't put that back in. Left it off for now. Let's try this again. Power on. Booting. That pulled 81 watts there for a minute, I saw. Fans are knackered. But it's going. Fans need replacing. All the fans need doing. Let's push that. There we go. Output's on. It's complaining about something. Complaining about batteries. But the output is on. It's drawing 60 watts. Okay. So it just isn't happy with the batteries, which I'm not surprised by. Let's have a look. 12. 8. Oh, that was really bad. 12. 12.7. 20. Well, that's not good. 12. Okay, because that middle battery being no good, it's killing the other batteries. So the best thing to do here is to turn the thing off and leave it off. If I can. If I can turn it off. Well, at least now it's not charging. The voltage should be got off that battery. Back down to 9 volts now. This is 12. Yeah, so we've got some really bad batteries. All these batteries need replacing. There we go. It's killed itself. Great. It's working, it's fixed, apart from the batteries and the fans. So I think I might leave the owner to deal with those. I don't need to fix those things. He can fix those himself. He's more than capable of doing that himself, but he had some issues trying to get the thing to power up, and obviously I've managed to find a problem there. I'm going to call that a fix. I can give it back to him, and he can replace the fans and replace the batteries. I'm sure he can manage that just fine. Subscribe over there if you're not already subscribed. Other videos to watch down there, and also in the description. And if you think my channel is worthwhile, there's a Patreon support link up there where you can support the channel, a couple of dollars a month, and it helps me to make content. Catch you later.